All right, we're recording. Okay, so look in here. How many centiliters, guys? How many centiliters are in 4.3 kiloliters? So who thinks they got the answer to that? Yeah, go ahead. 430,000. That sounds plausible. Let's check it out. Let's see if that's correct. So remember, when you do this, you always start with the number they give you. So they're giving us 4.3 kiloliters. So right, 4.3 kiloliters.
Is this gonna be like test?
No. Remember, I can't test you today. So like, we're starting a new unit, and then this is going to be.
Totally different. I'm pretty sure you're not allowed to learn any material.
Yeah, but Mr. Prelaw, I told you, I'm gonna. Next class, we're reviewing. I can teach you new stuff. I then review it the next class. You know.
We take a test of this? This is a loophole.
We haven't. This is reviewing the last stuff.
This is a loophole.
Okay. All right. Can I do my thing?
Infinite money for it.
Do I have y'all's permission to get up here and do my
Yes,
thing?
of course. Yes.
All right. Thank you.
Yes.
Okay. So write down the unit you're starting with. So you got kiloliters here. Whatever the unit is here, that old unit goes down here. So kiloliters is there. Kiloliters goes there. That way, kiloliters cancels itself out. Okay. Now then, the unit you want to find goes up here. Now, what we're trying to find is centiliters. So ideally, you would put centiliters up there. But the issue is you don't know how to go from kiloliters to centiliters, right? Or at least I didn't teach you how to do that. So we're trying to find centiliters. But what do you know how to get kiloliters into? Liters, right? So let's go to liters. All right, well, what's the conversion from liters to kiloliters? That's one of those conversions I said you had to memorize. Kilo meant what? Not 100,000. Centi was 100. Kilo's 1,000, and it's big, meaning in 1 kiloliter you could fit 1,000 liters. Okay. All right. Now then, if liters is here, liters got to go down there, and then we're trying to find centiliters, so then we'll put centiliters up here. So liters will cancel, and then what's the conversion from centiliters to liters?
So it's 100 centimeters.
Yeah, good. Centi. Things are like 100 cents in $1. So 100 centiliters are in 1 liter. Okay. So then, remember how this setup is: numbers on top you multiply, numbers on the bottom you divide. So you do 4.3 times 1,000, then times 100, and then you divide by the numbers on the bottom. So you can skip dividing by 1, guys. Will. You can skip dividing by 1. So if you do 4.3 times 1,000 times 100, confirmation we get 430,000? We good? All right. So you get 430,000. I'll write that down here. Okay? All right. Now, yes, I understand that we already did that, but we're going to be using that same method. So go ahead and get the notes, the new note copy in front of you. We're going to use that to talk about something called the mole. So, what is a mole? A mole is just a way, let me back up. What is a dozen? 12, right?
12 bagels or donuts.
12 bagels are, yeah. I said I got a dozen donuts.
What is a bagel?
I'm pulling up with a dozen donuts. I'm pulling up with 12 donuts. Now,
You got us on Friday?
a mole is just a number. Okay? So I'll tell you what the number is, but just keep that in mind. It is if you want to get all technical, it is a collective noun used to define a number of a certain number of particles. Okay? All right, so everybody, we got new notes here. People should go and be filling out notes.
So a mole is a
What are we doing here? Don't like too much Halloween candy last night.
A mole is not just 12.
Okay, a mole is not 12, but it's a number kind of like a dozen means 12. Okay. Now then, let me get my cursor over here. What is a mole? A mole is a really large number. It is 6.02 times 10 to the 23rd. So if you said, hey, I'm pulling up with a mole of donuts, you're pulling up with that many donuts. I don't even know how it's possible. 6.02 times 10 to the 23rd. You're like, I don't even know what that means. That means this. It'd be a number that is gigantic. Now, you're like, okay, well, why is a mole so large? Why would we use a number that's really large? Because atoms are really small. What we're trying to do is, if I were to give you like 25 grams of gold, if you want to answer the question, well, like, how many like individual gold atoms is that? How would I represent that? That's where the mole is going to come in. The mole helps us bridge the gap between grams of a certain element and the number of atoms of a certain element. Because an issue arises if you were trying to go from grams of an element to atoms. That issue is, well, each element weighs a different number of grams. If I had 5 individual atoms of gold, that's going to weigh differently than 5 individual atoms of zirconia. Okay? The mole helps us bridge that gap. Yeah. All right. So this is what I'm talking about. So if you look here, you got this one. So here would be 1 carbon atom. Here would be a dozen carbon atoms. Remember, I said a dozen is 12. Now you're like, but what does a mole of carbon atoms look like? This would be a mole. Okay, 6.0222 times 10 to the 23rd atoms. We call that number the 6.022, and it can get expanded out 6.02214. You can even just say 6.02. That's fine. That's called Avogadro's number. So you're going to get very familiar with Avogadro's number. But again, 1 mole of carbon atoms would be the same number of atoms as 1 mole of oxygen molecules or 1 mole of carbon dioxide molecules. If I said I'm pulling up with 1 mole of donuts and 1 mole of carbon atoms and 1 mole of oxygen atoms, you're pulling up with the same number of each of those. That number is 6.02 times 10 to the 23rd. Okay? They have a different mass. You put them on a scale, they would weigh differently, but the actual number you would count out is the same. Okay? All right. You're a little confused. That's okay. A little bit more on the mole. So again, it would be very, very difficult for you to count out a mole. Like it is the number is 6.02 times 10 to the 23rd. That's very difficult to count that out, right? Fortunately, what the periodic table tells us is the mass number that we learned about. We said mass number was protons plus neutrons. And this was the average mass of like all the magnesium atoms, for example, in the universe. So that mass number could either tell you the average mass of a single magnesium atom, but that mass number will also tell you what the mass is for 1 mole of magnesium atoms. Really let that sink in. So if you were to count out 6.02 times 10 to the 23rd individual magnesium atoms, and you put them on a scale, that scale would read 24.3. If you were to take 1 individual magnesium atom, its mass would be 24.3. Now the units are different. The one atom would just be atomic mass units. It's not grams, it'd be atomic mass units. Okay? All right. So again, trying to get you to understand the difference between atomic mass and molar mass. Atomic mass, again, mass of 1 atom. Molar mass is the mass of a whole mole of them. Remember, a mole is 6.02 times 10 to the 23rd of those individual atoms. This would be 1 carbon atom. This would be a whole mole of carbon atoms. Did you know charcoal is made of carbon? I don't know if you knew that. Fun fact. Now, looking at units, grams per mole. Don't worry about that as much right now. I'll talk a little bit more about the units we'll use some of these practice problems. But again, I just want you to understand a mole is just 6.02 times 10 to the 23. Okay? Just get that turned on. All right, now these are the kind of problems you got to be able to do. So they're wanting to know, hey, how many moles are in 75.3 grams of neon? So what you do, just like we did in the warm-up, write down the number and the unit you start with. We start with 75.3 grams. Grams of what? neon. Okay? Neon. Remember, whenever you set up your boxes and stuff, you could put this over 1 if you'd like, or just leave it blank. Okay? Yeah, you're good. And then if grams and neon's here, grams and neon needs to go diagonal. And then up here, this is the unit you want to find. What are we trying to find? Moles in neon, right? Moles in neon. Okay. Well, what numbers do we use here? Well, yeah. Actually, no, we will use that in some of these problems, but when you're just going from grams to moles, you would actually say in 1 mole of neon, find neon on the periodic table and use the mass number that it has. So its mass number is 20.2. Where you're going to use the 6.02 times 10 to the 23rd is if I ask you to go from moles to atoms. If I were to ask you how many individual atoms are in this many moles of neon, that's when you'll use that early number. We'll do a problem like that. Right? If you're going grams to moles, you use that mass number on the periodic table. Okay, now then how you do the math. Again, numbers on top you multiply. So this you do 75.3 times 1, which you can just skip, right? It's going to give you the same number. Numbers on the bottom you divide. So then divide by 20.2. And if you do that, you get 3.73. And 3.73 what? Well, it's a unit that didn't cancel out. It's moles of neon. Okay? So, in other words, this really shouldn't be that bad if unit conversion made sense to you. That's why I really want to get you to buy in using that dimensional analysis method, because then this is where like it becomes applied to chemistry. Okay? All right. Let's do another problem. Let's say they say, hey, how many moles are in 15.7 grams of aluminum? Well, write down the number you're supposed to start with. We start with 15.7 grams of aluminum. Write that down. 15.7 grams of Al. Okay, put that over 1. Okay, if grams of aluminum is here, got to put grams of aluminum diagonal. Okay, that way these cancel out. Everybody still with me? We're still writing? Still awake here? Not dreaming about your Halloween candy? Anybody get a good Halloween candy haul? No? No? Jeez. Okay, yeah. Whatever. Now, up top, this is the unit you're trying to find. We're trying to find moles of aluminum. So moles of aluminum, you're going to go up here. Now then, what numbers go here? Well, if it's grams to moles, this is where you, or moles to grams, that's where you got to use the mass number on the periodic table. Yep. Yeah, good. So yeah, you would use the mass number for aluminum. Now, to make the number simpler, you could just round that to 27. If it's close to 27, you're going to use 27, and that's in 1 mole of Al. So really make note of what we did there. So we're using a different grams number than the previous problem because we're not using neon. Now we're using aluminum. So aluminum's average atomic mass is different from neon. Yeah.
We're basically saying that in order to find the moles, you just have to look and then look at the
Look at the mass number. Because again, what this is saying, 1 mole, a mole is just a number. What is that number? I'm pulling up, you're pulling up with 1 mole of something, how much are you pulling up with? 6.02 times 10 to the 23rd. If you took that many aluminum atoms and you on a scale, that scale is going to read 27 grams. That's what that means, okay? Alright, so then to find the number of moles, you would just multiply the numbers at the top, divide the numbers on the bottom. And this would be in moles of aluminum. So you do 15.7 times 1. And then divide the numbers on the bottom, so then divide by 27. And if you do that, you should get 0.58. I don't remember. We don't have to worry about significant figures in here. I don't. 2 decimal places is pretty normal for these. So there you go. All right. Let's. Any questions so far? We okay? Let's keep doing some more problems. Now, before we get into doing something with atoms, I want to remind you of how to use scientific notation. So I talked about this when we were doing Unit 2, but just a reminder, if you have like a graphic calculator or something, if you want to type in Avogadro's number, you got to do 6.02, and that E button represents times 10 to the power of. So if I want to type 6.02 times 10 to the 23rd, to get to the E, you do second, comma, and that will give you the E, and then again, that is times 10, and then you would type 23. Okay? I'll go through individually if that's confusing to you. It can be a little different for different calculators, but for second, and then you're going to click the comma button. You're trying to access these blue numbers. So the second button, do you see the second button on your calculator?
Yeah.
Okay. And then the comma is right above the 7 button. So find number 7, it's the button right above it.
Yeah, I have been doing it. Whenever I enter it, it just says there's an error.
Okay. I don't want to get bogged down with it. If you're having issues typing on your calculator, I'll just address that separately when we're done with the notes. Okay? I'll go around and help you out. Okay, so now let's apply kind of let's do like a different type of problem. So here they're asking us how many atoms are in 75.3 grams of neon. So you pull up to the party with 75.3 grams of neon, and people are like, "Yo, how many atoms are that?" Right? How many atoms are in that bag? Well, you have grams of neon right here. Got to put grams of neon right down there, right? So that grams of neon cancel. Well, what's the unit you're wanting to find?
Atoms.
We're trying to find atoms, right? So the issue is you can't put atoms of neon up there. There is no way, and make sure you make this connection. You can't go from grams to atoms. There is no straightforward one-step conversion because every element weighs differently. There's no one way to do. That's the purpose of moles. Moles is that way, that middleman to get us between grams and atoms. So yeah, good. So then we're gonna do moles first. So first, we're gonna go from grams to moles of neon. Okay? Now then, this is just like the previous problem. Where you find grams in neon, look on the periodic table. Find neon. And neon is right there. It's 20.2 grams of neon are in 1 mole of neon. Okay? Now then, if moles of neon's here, has everybody ever written this down? Everybody still with me? Moles of neon's here, moles of neon's got to go down there. Okay, that way they cancel each other out. Now then, what are we trying to find? Don't lose sight of what we're trying to do. Trying to find atoms, right? So then atoms of neon is going to go up here. Okay, well then what are the numbers that go there, right? Now that's where we're going to, yeah, now we're going to, but where does that number go? Does that number go up here or down here?
Top.
Think about, what does that number mean? What does it mean? How many atoms you are, but how many atoms in what? In a mole. So in 1 mole, there is 6.02 times 10 to the 23rd. Again, a mole is just a number. If I had dozen down there, this would be 12. A mole is just a number. It is a gigantic number called Avogadro's number, and that's 6.02 times 10 to the 23rd. Okay. The reason why you have 6.02 times 10 to the 23rd is because 1 mole of anything is that number. Just like 1 dozen of anything is 12. Asking why that is 6.02 times 10 to the 23rd would be like asking why, if you have a dozen down there, is that number 12? It is because it is. You know, it's been accepted in the scientific community that a dozen is 12, and then a mole is 10. Exactly. It's just been an accepted kind of thing in science. Okay? All right. Now then, doing the math, multiply the numbers on top, and then divide the numbers on the bottom. So we're going to do 75.3 times 1 times 6.02 times 10 to the 23rd. So this is where you got to be able to know how to type in your calculator. Then divide the numbers on the bottom. Then you would divide by 20.2. Remember, you can skip dividing by 1. And when we do that, we're going to get 2.25 times 10 to the 24th atoms of neon. Okay? So again, understand what you just did in that problem. What you did is you went to a party carrying a bag of neon, and somebody asked you how many atoms are in that bag. And so you broke out your calculator, took out a piece of scratch paper, you ran the numbers, and you said, actually it's 2.25 times 10 to the 24th atoms are in this bag. Okay. Yep. Let me, we'll talk about it. Let me get through the notes and I'll help you out with this. Okay. Yep. Sorry, Mia, give me a second. People are being rude to you. Will. Yeah, so you do 75.3 times 6.02 times 10 to the 23rd. And then divide by 20. That's how I got this answer. Okay, moving on. Let's do another problem. But now, let's do 15.7 grams of aluminum. So, start with the number they give you. I think this is the last problem I have for you. One of the last ones. So, you got 15.7 grams of aluminum. Okay? You can put it over 1. Now then, everybody still with me? Guys back there? All right, on the new problem. Grams of aluminum is here. So then grams of aluminum is going to go down there. Okay, can we get that phone put up for me? Okay. All right, so then this way grams of aluminum cancel out. Now, we're trying to find atoms of aluminum. But again, I'm going to say it again. You can't go from grams of aluminum to atoms of aluminum. I don't care how badly you want that to happen. It just can't happen. There's no way to convert between those two things because every element has a different mass amount. That's why moles exist. We go to moles so that we can then go to grams. So we got to go from grams of aluminum to moles of aluminum, where in 1 mole of aluminum, the number of grams is where you're going to use the periodic table. Find aluminum. Aluminum's right there, and we said its molar mass was about 27. So we can round that up to 27. Keep the numbers easier. But then we're not done yet because we're only at moles of aluminum here. So let's do another one. Let's go from moles of aluminum to now we want to get ourselves to, can I get that phone put up, please? To now atoms of aluminum. That's what we're trying to find here, right? So we got atoms of aluminum on top. Okay? Appreciate why atoms of aluminum is on top, because you need moles of aluminum to cancel. Okay, now the numbers here. 1 mole of anything, I don't care if it's candy, is what number? 1 mole of anything is what? 6.02 times 10 to the 20. Thank you. Okay? All right, now then, to find your answer, and the answer is going to be in atoms of aluminum, you got to do 15.7 divided by 27, divided by the number on the bottom, and then times numbers on top, times by 6.02 times 10 to the 23rd. And when you do that, you're going to get 3.5 times 10 to the 23rd atoms of aluminum. Okay, we got that written down? All right. Almost done here. I want to talk about one more thing. So you're looking at this problem and you're like, I recognize that font from somewhere. That's got to be a Snagit from somewhere. Where did he Snagit it from? Got to be from your test. So here's a kind of question you would likely see on a test. What is the mass of 6.02 times 10 to the 23rd atoms of sulfur? You count out that many sulfur atoms, put them on a scale, what would the scale read? How would you figure that out? I get that the answer circled there, but how would you find that answer?
Go to sulfur, and you send it up.
32, so first.
Yeah, good. You don't know. Yeah, find sulfur on the periodic table. What's its mass number? 32.065. So it would be that answer. Now, but here's the issue. Yeah, but there's a lot of 32s up there. So which one do I choose? Which one has the correct units? I had this up here because a lot of people miss this question. People find the 32 all right, but then they're like, it's 32 AMU or mass units. It's grams. Okay. All right. So go ahead and start working on that worksheet. I'll be going around if you have questions.